discussing one of the latest technology nowadays which we are using just to prepare the electronic gadgets, that is the printed electronics. So today we will discuss regarding the printed electronics, how we use the printed material for the development of the electronic gadget. As we know that the things are going to be miniaturized, so in this regard we require the miniaturized devices. So to create them we use the printed electronics, so that it will be of the smaller size, nano size, or sometimes this technology is used in the smallest gadgets. So what is this printed electronics? Printed electronics is a special type of manufacturing where electronic components, circuit and systems are developed on a wide variety of the substrate. Mean we take the substrate and on that substrate we just create a circuit as well as electronic component as well as a system. And in the similar fashion as the drawing text and figures on a paper, textile and handicraft. So this printed electronics is just similar as we draw a text or a figure on a paper. Similarly, we draw a circuit on a substrate. So the difference between the normal printing and the printed electronics is that in printed electronics, functional material is used as the ink that exhibits functionality of insulator, conductor and semiconductor materials which are essential for the electronic devices. It means when we take the substrate, then it should be compatible. Number 2, we take the ink through which we just create a structure, it should be of the accordingly insulator, conductor and semiconductor. So these material functions for the electronic circuit. So in the printed electronics, which is a branch of the electronic manufacturing and electronic material science that develops and applies organic and inorganic material to create the discrete component system or the entire devices by means of the sequential or parallel material additive technologies such as screen printing, ink printing or the direct writing. So in its pure form, a printed electronic device is realized by fabricating conductive traces as well as required passive and active electronic components directly on the organic flexible substrate or on the paper or on the sheet. We can prepare the electronic component as well as we can create electronic circuit or we can create electronic system through this printed electronics. And we also use the passive and active electronic components but in the form of the printing form. So today this is only the possible for very simple electronic designs. Typically a hybrid technology approach is employed in which most of the discrete electronic components are attached to the printed conductive traces on the flexible substrate using the conventional packaging methods such as surface mount technology. In the surface mount technology, we use the PCB and on that just we trace the electronic gadgets, to attach the electronic gadgets. But here just we take the flexible substrates and on that we create the electronic devices. One of the pillar in the printed electronic technology is the capability to create the material structures with defined chemistry, geometry and properties on the organic substrate. For the most printed materials, this is the two-step process that involves the material depositions followed by the appropriate post-deposition treatment. It has a two process. Number 1, material deposition, which is followed by the post-deposition treatment. Now the printed electronics is some of the features are, it is a fast, highly automated, suitable for the large scale industrial production. We can create a mass production by using this printed electronics at the lower cost. Moreover, it gives a highly precise instrument. Moreover, printed uniformity is the good, and we can achieve the miniaturization of the electronic devices through this the printed electronics. Use a small amount of the conductive material, and hence the cost is very low. So the product quality is stable, high yield, or moreover it is a green and environmentally friendly, and who just create the no waste, and it will not harm the environment. So they are the main features. So we use and we inspire to work on the printed electronic technology. When electrical device is created through the printed process, it is designated as the printed electronics. When we create electrical devices through the printing method by using the simple printer or the other printer, so that devices is known as the printed electronic devices. And over the 20 years, the manufacturing industries has been using the various printing technologies to produce the antenna, sensor, membrane, switches, MEMS, CMOS, other devices we can use by using this printed electronics, so that our things are going to be, electronic gadgets are going to be miniaturization. That is the main reason the manufacturers use the printing technology. So this list is continuously increasing. Today user demand for the low cost, flexible and the smarter products. We use the printed electronics, and the printed electronic fabrication technologies therefore the contributing to the novel and the better product. The interest on the flexible electronic system to be used, if you take an example, so on a non-planar surfaces grew tremendously in the recent years in the areas such as aerospace, automotive, biomedical, robotics and health application. We use the printed electronics, and this is possible thanks for the combination of the different polymeric material which we use for creating the electronic gadgets compared to the traditional silicon substrates. Means we can change the substrates, not only the silicon, but we can take the paper, PET and other type of substrates which are flexible. Moreover, the cloth we can take on which we can create a circuit through this printed electronics, and the new coated and the printing techniques able to work at a temperature compatible with the polymeric substrate. Means if we just take the sensitivity about the temperature, so we can take the polymeric substrate. Even the manufacturing of the non-polar surfaces otherwise impossible with the odd fashions fabrication technologies. So the use of flexible polymers where we can use the printed gadgets has a many advantages compared to the traditional hard substrate, including the higher contact area, capability to fold, roll, lightweight, easy to use, and it can be compatible with the movements. So we use the flexible polymers, and therefore they have a key role in the development of the new conductive circuit. Now, each technology is selected according to the type of the electronic component and devices. Means we require the small, thin, lightweight and flexible and inexpensive and disposable devices. So, the production and the cost and the volume, the essential aspect of the success of any type of the printed electronic devices is the processability, performance and the long-term reliability. Moreover, the cost effectiveness and the efficiency of the material which we are using for the printed electronics. So, the pastes, ink or coating can be based on both the organic and inorganic material according to the requirement. So, as we are printing, so we require the ink, or we require the paste or require the coating. So, inorganic ink normally contains a metallic like copper ink, gold ink, silver ink and aluminum. nanoparticles. So whenever we prepare any devices, so we require the gold, aluminum, silver nanoparticles dispersed in the retaining matrix, and they are used in the fabrication of the passive components and transistor electrodes, transducers. We use this ink and paste. So organic inks are based on the organic material such as polymers, conductors, semiconductors and dielectrics. So the ink based on high conductive polymers and employ in the batteries, electromagnetic shield, capacitors, resistors and the inductors, sensors, etc., while inks based on the organic semiconductors. And what are they? And just the active devices can be prepared by using the organic ink, like organic photodiode, organic light emitted diode, organic field effect transistor, organic solar cell, organic sensors, by using this organic ink that we use for the printed electronics. Due to the wide range of the printing technology, the material must meet the certain requirement depending upon the type of printing being performed and on the application where we are using these electronic gadgets. So printed electronics is a very latest technology, and it is divided into the two categories. So printed electronic technologies can be divided into the two techniques. Number one is the contact techniques, number two is the non-contact techniques. By using these two techniques, we can manufacture the electronic gadgets or electronic devices. So first is the contact technique. What is this contact technique? In which the printing plate is in direct contact with the substrate. Here we are having the printed plate in the direct contact with the substrates, means we are having a substrate, then just we print on it through the direct contact. Next is the non-contact techniques. Non-contact, as the name suggests, that there is a gap between the substrate and the material which is deposited, means where only the deposition material get in contact with the substrate. Otherwise, there is a printing plate is in a direct contact with the substrate, but here only the deposition material get in contact with the substrates. So there are some example of the contact technique you can see on the print, that is a screen printing, flexography, groove printing and the soft lithography. These are the some of the contact techniques. Another non-contact techniques are the laser direct writing, aerosol printing, inkjet printing. These are under the non-contact techniques. We will discuss one by one both the techniques, contact techniques and the non-contact techniques. You can see the chart where we are having the printing technologies are divided into two, non-contact printing and the contact printing. Roll to roll printing we are having in between that, and moreover these two are also divided into the various type, like non-contact techniques having the inkjet, like the slide printing, like the electrodynamic printing, like screen printing. But moreover the contact printing also have the groove printing and offset printing, flexography, micro contact, nano imprinting, dry transfer printing. These are the various techniques which we use for the printing electronics. Now we can have the contact based printing technologies. We will discuss one by one how many types. In the contact based printing techniques, pre-patterned structure of the printing tools are physically brought in the conformal contact to the target substrate. Means contact, there is a contact between the plate and the substrate. Similarly, micron scale dispensing nozzles are used for the high resolution patterning by contacting the target surface in the similar fashion as the drawing. So almost all the techniques used in the contact based printing are precise and rapid. Therefore, these techniques are used by the industry for the mass production. Printing through there is one of the most important advantage of the printing technology is that we can produce the mass production through this printing technology at the lower cost. Now we discuss the one of the contact technique, that is the screen printing. Screen printing remains the top priorities when it comes to the rapid, fast and the large area manufacturing. So the technology has been using from the earlier development stages of the microelectronic industry, especially for the printing electrodes and the interconnections. So in the screen printing, we have the advantage that when it is compared to the other printing system, as it is a more versatile and processing is very simple, capable of the reproducing similar structure in the large batches with the minimum dimensional variation. So results are duplicated by repeating the similar printing parameters and the optimized solution paths. So we can create the repeated pattern, we can create the duplicate pattern through the screen printing. Screen printing process can be established following the two different assemblies. What are they? Number one is the in flatbed and installing a rotating surface. So we can work the screen printing on the two different assemblies. One is the flatbed or the next is the rotating surface. In the flatbed system are usually applied for the low throughput production and the lab level research activity, whereas the rotary system are installed on the fast production platform such as R2R, where all the solution and the printing parameters are optimized first and applied afterwards for the high speed production of the devices. First the prototype is created, then that used again and again. Now you see that this is the screen printing system. On the screen you are having the screen printing system. Now we have the just a broader form of that. We have a slide, we have a ink, we have a screen, we have a template, we have a substrate and moreover base. Base is the first we create the base, then we have the substrate, then on that substrate we have the template, then template, that is a mask, that what structure we require to print on that substrate, we create a template or we create a mask. Now about that mask, just we put the screen, and on this screen we put the ink, then we blend this and we spread this ink on this screen, and this will imprint on the substrate. So in this manner we can get the devices structure or the material structure on the substrate. So the system setup is very simple, which contains the screen, squeezy, press bed and the substrate placed on the movable stage. So in flatbed system, the printable solution is applied on the screen, and the squeezy is used to coat the ink all the way over the structure mesh on the stencil. So we just flow the ink on that stencil, and we can get the equal pattern through that ink on the substrate. So a controlled pressure ensures the dispersion of the ink throughout the holes in the mesh, and the squeezy recollects the extra ink for consequent layers, so that a flat pattern we can get or a systematic pattern we can get on the substrate. So flatbed screen printers are ideal for optimization of the process and the structure on a small scale lab research. So for high speed production, a folded screen with the squeezy inside the rotating and the ink filled in the tube are applied on the continuously rotating system. However, the screen For rotating screen systems are expensive and challenging to clean the case of the material clogging. So, whenever we require the mass production, we use the rotatory screen so that it can imprint the same pattern on the substrate. But the disadvantage is that it is very clear that the cleaning of the material through clogging is necessary. So, the print quality in both the approaches is affected greatly by the similar set of the parameter such as the solution viscosity, printing speed, angle and geometry of the squeegee, standoffs between the screen and substrate and the mesh size. All depend upon the all will be affect the printing quality of the electronic gadgets. So, material properties are turned separately to have the right viscosity, surface tension for complete dispensing throughout the screen. Moreover, the ink should flow smoothly so that the pattern will be neat and clear, and there should not be any breakage in the any gadget or any printing. So, viscosity of the pastes used with the screen printing is kept higher than other conventional printing technology in order to avoid the undesired flow through the screen mask, so that it will coat evenly. So, screen printing is used for both the printing pattern structures and the coating larger areas. Pattern resolution in the ranges of 80 to 100 micrometer can be achieved after the proper tuning the solution properties, optimizing the screen printing parameters. A good compromise between the surface energies of the substrate and the surface tension of the ink is desired to achieve higher resolution. So, we require the good surface energy of the substrate as well as the surface tension of the ink we require to get the higher resolution. So, the type, material and the strength of the mesh used in the screen also contribute to the high resolution patterning throughout the screen printing. Means the screen we are creating, it should be properly geometrized so that there will be no breakage, no flaws created in the electronic gadgets. So, different materials such as nylon, polyester, stainless steel are used in the screen mesh. Means we are creating the screen mesh as we are just giving the pressure on that. So, on the basis of that we select the different material for producing the screen mesh like nylon, polyester and the stainless steel. For printing stability during the mass production, a screen made of the stainless steel mesh so that it can be used again and again with the 3 times more in the strength that of the conventional stainless steel mesh has also been developed. So, the possibility of printing relatively thick layers could enable printing of the low resistance structure. Also with the conductive polymers by compensating the high volume resistivity with a thicker layer. So, the screen printing has successfully used for demonstrating various fabricated devices. For instance, if we take all the screen printing has been adopted for developing the thin film transistor. If anyone says that what is the advantages of the screen printing, then we just develop the thin film transistors by using this screen printing. OLED devices also presented by exploring the different process parameters such as viscosity, mesh count and their effect on the printed structure. So, an advanced screen printing approach is adopted to develop the multi-layer high-density flexible electronic circuits connected through the holes and the embedded passive and the optic devices. So, printing interconnect lines between the discrete devices on a same substrate or a tape out of the data usually printed with the screen printing. So, now this is all about the screen printing. Now, we will discuss the next contact printing technology in the next lecture. Thank you very much.